Hello, everyone, and welcome to this session with ProSoft Technology, where today we're going to talk about improving your smart conveyors efficiency with reliable wireless solutions. I'm Keith Wodorn, the Director of Product Management for ProSoft, and I've got with me today Steve Richardson, who's our Regional Sales Manager in the Central Region and our resident expert on conveyance systems, particularly in automotive. Welcome, Steve.
Hi, Keith.
So when we talk about conveyance, today we're going to be focused on automotive, but a lot of these same technologies and problems exist in a lot of different industries. Let's take a look at what automotive companies are doing today around mobile automation. There's a couple of different types of conveyance that we see in plants all the time that the automotive manufacturers rely on in their process. We have things like skillet conveyors, EMS conveyors, and automated guided carts. So Steve, a skillet conveyor, tell me, what does that do?
Basically, a skillet conveyor is, if you're looking at the photo, the skillet conveyor is a table, if you will, that allows operators to be able to stand still and be positioned on that table as it is pushed around the conveyance system throughout the different stations of the build process. So throughout each of those stations, the lift for the skillet raises or lowers depending on which station that it's in to give operators entire relief for the work that they have to do. So the entire goal of a skillet conveyor is to make sure that operators are not bending over and hurting themselves while they're building.
That sounds like a good thing. So that probably also increases the flexibility of that line for the automotive manufacturer too, doesn't it?
Correct, yes.
All right. And EMS conveyor, it looks in that picture like the carrier is moving a chassis around on a rail. Is that basically how those work?
Correct. And some EMS conveyors, they also change height depending on what station you're in as well for ergo, or they may rotate or angle the particular part depending on what is best for ergonomics.
Great. And finally, we've got the automated guided carts, or AGVs, or also AGVs. Looks like those are shuttling parts to and from the production line and doing some other things. Is that how those work?
Correct, yes. Typically, automated guided carts are for delivering parts to the line for logistics, but they also are used at different times for building different components for the vehicle or the product that the manufacturer is using.
Great. Excellent. So one of the trends that you and I have spoken a lot about is around this smart conveyance idea, where automotive manufacturers and really manufacturers in a lot of different industries are trying to respond to the demands in their markets to be more flexible, to build multiple different product lines or product types on one line, for example, multiple vehicle types. And smart conveyance is sort of the way that's one of the ways that progressive manufacturers are going about doing that. Do you have any examples of how that translates in automotive? What are companies doing to achieve that and that kind of flexibility?
Great question. So let me back up for a second. And traditionally, automotive plants use power and free conveyor systems or chain on edge conveyor systems, or carriers that are not flexible at all. So when you speak of flexibility, flexibility comes into play with either adapting the process to the operator or just let's say, getting the vehicle to the correct height or the correct positioning for somebody to be able to get the component that they're trying to add to the product at the time. So as I said, traditionally it was power and free conveyor. Now you see a lot more automotive players that are trying to make the system more flexible. One, so that they don't have to install monuments, because let's say a power and free conveyor is something that when you put in, you would have to take the entire plant down for a significant amount of time to be able to change the conveyor. So you don't really have any adaptability built into the conveyance style. Automotive players are also looking at what they can do to increase safety, quality, as well as just the overall ability for operators to build more efficiently.
Great. Okay, so let's take a look at some of the ways conveyance happens in the automotive world today. There's a lot of different legacy systems out there, a lot of different ways to get parts to move around a plant. The first one here that we'll take a look at is standard bus bar or conductor bar system on a rail. Tell me a little bit about this approach and how it works and what the limitations are.
Okay, so in this particular type of system where it's bus bar control, this would be more for let's say a EMS conveyor or for a let's say even a skillet system type of conveyor. Now, what they're doing with this type of setup is they're using the first 4 bus bars to power the motors or the automation that's on board the conveyor. So with that, they're providing power to every single carrier that is in that specific power zone, which in most cases is a lot of carriers depending on the size of the system. With the second 4 bus bars that are shown, this is where the control system can get its different commands that can be given to the carriers that are on board that system. So as you're seeing up above, for example, control may be, say, run forward, run reverse, help needed, or requesting a carrier. Now, the challenges with this is you're commanding every carrier at the same time. So there's no flexibility built into it. So if you're telling all to run, if you're telling one to run forward, you're telling all to run forward. If you're saying that you need a new carrier, you're saying, give me a new carrier, but not necessarily where this particular carrier is. Or with help needed, you're saying, I need help on this particular station, but there's no way to explain to, say maintenance or to production that you're asking for help at, say, carrier number 3 on the line versus, say, carrier 10 or 20 or 30. You have no way of being able to say this specific carrier is asking for help or this specific operator is asking for help at this specific time. So on the one hand, yes, this enables you to be able to have mobile automation where the carrier can do different things, say run forward or reverse or even raise or lower, but you don't have the ability to control what that carrier is doing individually. And you don't have any diagnostics for what's going on with that particular carrier at that particular time.
So this sounds like it's not very different from Henry Ford's day of a big chain moving everything along through the plant at the same speed then.
Correct.
All right. Well, things have kind of moved along. We got some new technology, and some systems started using this black box to control the motors on the carriers. Now, how does that work?
So the way that this type of system works is more so, let's say you have the black box, as you mentioned, controller. The black box controller has some type of smarts to it, some type of motor controls. It can accept certain inputs from the system as a carrier is moving along it. But well, it accepts those inputs and it makes a decision on what it's going to do, and then it operates the motor or motors that are on that particular carrier.
Okay, that sounds like an improvement. Now, what were some of the downsides of the black box?
So there are actually several downsides to the black box. One of them being, as it shows on the slide here, zero flexibility. So when I say zero flexibility, meaning if the plant wants to adjust something to improve the process or to make the system more adaptable to the operator, then they have to go to the physical location of that specific black box. Or in the case of if they want to do the entire line, they have to go to every single black box to make updates to that particular set of controls within that black box. So there's zero flexibility or zero adaptability on a almost real-time or very quick basis. Most of the times you'll see that any changes are going to be done when production is not running. Now, another drawback to this type of system is there's a huge amount of wiring that is inside of these black boxes. So when it comes to electricians trying to debug what is going on within this black box, they're looking at a control diagram. They're trying to decipher what's going on with that control diagram, as well as looking at the wires within the box to understand what is going on, and hoping that they're choosing the correct wiring or the correct subset of wiring to look at. Now, when we're talking about the wiring or the controls inside of the black box, the next thing that comes to mind is diagnostics. Now, diagnostics on a assembly line is something that is very, very needed to help you be able to root cause a problem that's going on, or something that is out of the ordinary, so that you can quickly correct that problem or that issue and get the system back running at optimal rate. In most cases, when there's a problem in this type of system, you don't know before the problem actually stops your production line. It's generally production that is alerting their supervisor, alerting maintenance that something is not happening as the system normally works. And from that point, maintenance has to be dispatched, and maintenance has to come up to the device and read on the device out of a LED display or a pilot lights that are on board the black box what is going on. And then traditionally, you're going to see faulted or not faulted, or power is on, and you may see a fault. But the difficult part about that is with those fault codes, you have to look up on a specific list, which is traditionally a short list for quicker diagnostic ability. So you have this short list of fault codes, and you're looking to see, okay, what does this specific fault code mean? Well, this fault code may mean that there's a problem with the inverter that's controlling the drive. Well, you don't know what the problem is. You don't know, is it loss of voltage? Is it overcurrent? You don't know what is specifically wrong. You just know that there's something wrong with the inverter. So now this gives a lot more time to have to debug to be able to figure out, how do I make this back correct? And in some cases, it may be that the plant will just say, forget the flexibility of this particular carrier, make it so that it can run through the rest of the line, and then they will pull it off the line, and they will debug, which may take minutes, it may take hours, it may take days. So it's very inefficient from a production process where you're trying to build as many parts or products as you can without downtime. Another aspect of this type of control system that is not ideal would be from the safety standpoint. So in a system like this, where you have a system that's feeding all of these carriers, in this particular example, about 32 different carriers, it's feeding power to all of these black boxes at the same time. Well, in a safety standpoint, the aspect of safety is always remove the energy from the device that produces motion. So for you to put a single carrier in a safe state, you have to drop power to all of the carriers that are on that system. This adds more problems from the standpoint of now all of these black boxes have to boot back up. It takes time for them to boot back up, and it takes time before you can start your production line back from a single incident where you had to shut off power to the whole system. So all of the different topics that I've talked about they add to the mean time to repair. It's not a design that makes it so that you can quickly diagnose, quickly repair, quickly get the production line back running. It's all designed from a standpoint of, this is what we have available to us today. This is giving us some improvements over the previous type of system that we discussed, but it's still not giving us what we want. This is what customers are typically left with a design like this.
Good. So things to not choose, or reasons not to choose a black box. It sounds pretty straightforward, right? The flexibility isn't there. It's going to take a long time to fix. And in the at least in the automotive world, that downtime is something they calculate in the tens of thousands of dollars range. So that's a pretty important decision criteria, I would think.
Correct. In most cases, you have automotive assembly plants producing millions of dollars worth of profit per day, and as you said, tens of thousands of dollars per minute, or in some cases per 50 seconds or 45 seconds. So every minute counts with an automotive production line.
Right. That makes sense. Okay. So some other alternatives now are off-the-shelf parts. So I guess what this is telling us is we've got auto manufacturers out there who kind of put their own systems together or use some integrators and put these systems together with a bunch of different automation components. What kind of things have you seen in that area?
So in that particular area, as you stated, some automotive manufacturers choose to build their control systems with components that they can get from anywhere. Now, before I continue in that, if you'll step back for a quick second on the black box.
Oh, sure. Sorry. Oops, went the wrong way.
So one thing to note here with the black box, a black box is exactly as it sounds. It is plugged in and it does what it's supposed to do, or it doesn't do what it's supposed to do, and that's it. You don't have you don't know how it does what it wants to, what it's designed to do. So for this particular case, automotive manufacturers have to keep a lot of spare parts for these, so that if they can't figure out what's going on with that black box, then they can take the whole black box out, put in a whole nother black box, which in turn increases the amount of spares that they have to keep on hand. It increases the amount of money that they have to have sitting on a shelf waiting for a problem to occur. And in particular, the operators are still left with, when I plug this back in, okay, it should work, but it's not working. Why? I don't know why. So now if you'll go back forward.
Yeah, I'm going the wrong way. There we go.
So some automotive manufacturers choose to be able to build their control systems out of off-the-shelf components, whether it's contactors, PLCs, limit switches, encoders, proc switches, VFDs. They want to be able to go and get a spare part from their local distributor whenever they have a problem, instead of having to keep this on their shelf, or they don't want to have to wait for a very long lead time to have something flown in from a manufacturer that is on the other side of the world, just so that they can repair a system that they have. They want equipment that they know how the individual pieces work and how they can build them all together to achieve the type of control system that they want.
Okay. So let's see, what are the what are some of the things that we want to think about here for that? Looking at the drive control, using discrete I/O for that.
Yes. So in the long-term end goal is flexibility, increase in quality, increase in production, increase in safety. The question comes, why not to choose, say, discrete I/O for drive control? Well, in the particular case of let's say, discrete I/O for drive control, you typically have where you are able to determine that the drive is running or that the drive is faulted. You're able to reset a fault if there is a specific condition on that drive at the time. You can tell the drive to say run forward or reverse and run at a faster speed or lower speed, but you can't necessarily control what that speed is. Now, one big problem with having discrete I/O for drive control is you don't get diagnostics about what is going on with that drive. So if there's anything wrong, you don't know back at your control system, or your maintenance doesn't know, and and they have to come back, they have to go to the exact carrier, they have to open up the black box or open up the control panel and look in it at the drive to see what is the fault code. And then they have to go back and get a manual to look up, well, what does this fault code mean? And how does that play into what my drive or my control system is currently doing? So it's not very beneficial for trying to be able to get your line back up very, very quickly. It also doesn't give you the ability to adapt as you're going down the line for different conditions that are going on. So when we talk about flexibility, you will want to be able to say increase your speed or decrease your speed, and increase it at a gradual rate versus just switching from high speed to low speed. So these type of things, by not being able to switch speeds gradually, it actually adds more wear to the motor, the mechanics of the system, versus doing it in a softer and gradual way.
Okay, that makes sense. We've improved a little bit from the black box, but still have a lot of the same drawbacks.
Correct.
So position feedback. Now, first of all, why do we need position feedback?
So the reason why you need position feedback in any type of control system, especially a closed loop control system, the control system operates more efficiently if it knows that when I command it to do something, I am getting the reaction that I expected it to do. So with position feedback, whether you're moving linearly or in a horizontal fashion, or you're moving vertically, you're trying to adapt your control system to a new set point. And position feedback allows you to be able to measure whether you've actually moved to the set point that you asked for.
Great. And so encoders are good for position feedback, but maybe not so much on conveyance systems.
Well, yes, there's definitely encoders typically on a conveyance system, understanding whether it's the speed of the conveyance or where something is placed on the line. Encoders are definitely used for conveyors, I would say that.
Okay. And so what's the drawback?
Great question. So the drawback is not that you're using an encoder for feedback, or not that you're using per se an analog encoder for feedback. The drawback is, okay, when this encoder fails, how quickly can I replace this encoder, set it up exactly the way that the previous one that failed was set up, so that I can get my equipment back running at its original design or original state. So electricians typically, when you're replacing one of these encoders, electricians typically have so many different devices in the plants that they have to be responsible for, and they have to go back and get drawings or read the manuals on how to set up these devices. So you may have cases where the encoder will get rewired incorrectly, or the scaling of the output from the encoder has to be is not set back up exactly the same as it was before. So when that conveyance moves down the line and the VFD turns the motor on and is expecting this particular output, you're trying to get to a set point, but you may not ever get to that same set point again, or same set point in the same amount of time, because your encoder may not be scaled the way that the previous one was scaled. So
I see. So
it just adds to the amount of time to get the system back to its original state.
got it. So when all we've got are the 6 or 8 or however many pair wires are coming out of the encoder, it's definitely not an easy thing to work on and fix and get back to where it's supposed to be. All right. So another component that's used in conveyors are safety relays for control. Obviously, that adds to the safety component of the system. We've got parts moving around, heavy parts in the big plant. We want to keep everyone safe. So it seems to make sense. We'd use safety rated devices, but same kind of thing. They're missing some things that would help us produce better or faster.
And those things that are missing primarily are being able to debug the device and or replace the device quickly to get the system back up running. And in the case for say safety relays typically have a lot of wiring, say 10 or more wires on board them. They have some types of settings. They have some internal smarts to them, and they have very, very, very extremely little diagnostics that are available to them. So as you stated, yes, you have to have safeties, but how do you make the safeties designed so that your maintenance can quickly debug, repair, and replace, if they have to, one of those safety components?
Yeah, makes sense. And then serial protocols. So if our encoder in the previous example just has its wires coming out with its position, looks like we could instead use something that's giving us a network signal coming out. How does this work, and what's the disadvantage here?
So how this works, in this particular example, you're looking at, say, position feedback. So you have an encoder that moves along a strip, and depending on where it is along that strip, it's able to give you a raw position that can be used by that control system. Now, that helps in giving you the control system flexibility to say that I'm here at this location, I want to do X, or I'm at that location, I want to do Y. And also in this particular case as well, looking at, say, RFID readers. That may be an alternative to using a linear encoder. But with those RFID readers, you are at fixed positions along the line. And when you get to those fixed positions, when you get in that range of that RFID tag to that RFID reader, now you're able to read that information or send information back and forth between the carrier and the traffic cop of the control system. So you're able to get some flexibility. Now, the drawbacks that come along with this is the protocols and the wiring that goes along with these devices. So if you have a device to fail, using a serial protocols are, yes, they enable a lot more benefits than what you have with discrete controls. And they're great for engineers, but when you have, as I stated earlier, electricians that have to be responsible for so much equipment in the plant, they are having to go back and look at drawing sets or manuals to try to rewire these devices back in for them to work correctly. And typically, electricians don't know how to debug a RS-232 or RS-485 type of protocol. They don't have oscilloscopes. They don't have all day long to be able to try every different combination of wiring to see if they were able to wire it back correctly. They need to get the system up and get it up now.
All right. Now, some of the other components on here deal with interlocking the carriers. So I guess this is the carriers kind of know where the next carrier is and the one behind it. And is that what we're trying to accomplish?
So yes, with interlocking the carrier, let's say you have this mobile automation carrier that has to interact with some other automation or some other system that the existing control system does not have control over or does not know all the different details. You have to have some way of being able to control the interaction between the two. So traditionally with interlocking devices, whether you're using proc switches or you're using optical data transmission devices, you're only being able to get discrete information out of them. Say 4 in or 4 out, or 8 in or 8 out, 8 signals in or 8 signals out. So you're limited with the amount of information that you can send, and you are trying to design the system so that you can get the most out of that limitation that's there. It's not giving you your ideal case. So in the cases of, say, optical data transmission systems, you're relying on as it's called, optics. If those optics get dirty or if they get misaligned, then your data is either not going to come back over to the system, or your data is not going to come back over correctly to the system. Not to mention, you have no way of being able to tell whether this device particularly is failing or not working. So when that carrier comes into the system, it either works or it doesn't work. Are you starting to hear a common theme? It seems like a black box. It either works or it doesn't work, but no diagnostics.
All right. So it sounds like we've got a theme. We're looking for more flexibility in our production. The legacy systems didn't give us that flexibility. And worse, we didn't always have the best reliability or the best ability to identify a problem and then quickly fix it, right?
Right.
So, one of the ways that we see in our industry across all the automation industry is connecting up all these devices on Ethernet. Obviously, we know that gives us a lot more data, a lot more information. Tell me about what this looks like here for a conveyance system, smart conveyor in an auto plant.
So as you stated, the goal is flexibility and quick recovery and repair or replace of devices. So yes, Ethernet IP control systems, they come with a lot more data. They come with the ability for you to look and see what is going on with that individual device, say that drive or that I/O block or that encoder or that safety scanner. Yes, you have access to all of this data. So in this particular case that we're looking at, you have a safety PLC that is connected to the VFD, the I/O blocks, the encoders, the laser scanners. You have essentially a black box that is now built out of off-the-shelf components that you can write your own programs and control what it does. So now it's no longer that black box. It is something that is 100% flexible and up to the end user how they choose to use all of these components together.
Sure, that makes sense. And with the programmability and open tools, then you know exactly what's happening in there. So you've listed some things here. How does the Ethernet IP control system in particular help me, or I guess help our automotive friends and anyone doing the conveyance work?
The first thing that comes to mind is having the Ethernet IP control system, and being that you can use off-the-shelf components and you can program the system to do whatever your end objective is. The system is now very flexible. It is very expandable, meaning if you decide tomorrow that you need something new that you didn't have before, you could easily connect it up into the Ethernet IP network, and you can add more programming to it specifically for that new device that you added. You don't have to go back to the manufacturer of the black box and ask them to add or edit or adapt the system to your current needs. So this makes the system a lot cheaper to maintain, because your controls engineers can easily add, change, adapt, program Ethernet IP control system. Now, from a maintenance perspective, using an Ethernet IP control system, especially one with, say, quick connectors, if they have to replace something, they don't have to go in and unwire 5 or 6 wires from a single device to be able to replace it. They just unscrew that connection, replace the device, screw in the new connection, and now you have your power and your control over the new connection. So it's more of a, if you will, plug and play type of system. Now, there's some other benefits that comes from Ethernet IP control systems, specifically using certain type of VFDs that say Rockwell Automation provides, say the Kinetics 5700 or the PowerFlex 527. These both are, well, the PowerFlex 527 is a VFD, whereas the Kinetics 5700 is a servo drive. Both of these are used for motor control. And in this particular case, what you're gaining out of this Ethernet IP control system is you can now send those safety signals to that drive to put it in a safe state via Ethernet. So you don't have to deal with loose connections or the connections not put back in properly. It is purely, if you can communicate with the device, you can also control the safeties, and you can dynamically control the safeties based on what you want to do. Now, other benefits that come out of Ethernet IP control systems are you can create recipes based on what you need it to do. So let's say in the case of that skillet system or that EMS system, as you move to different areas of the line, the system can take the inputs of where you are and the devices that are around it, and it can produce specific outputs based on those conditions. So in one station, it may be one height, in another station, it may be a different height, in another station, it may be a different speed of movement to get to those different heights or angles that are there. And in all cases, an Ethernet IP control system, as you said, Keith, it gives you so much more data that now you can start tracking, why did I have this particular fault? Is it something that is mechanical, or is it something that is electrical? Is there interference that's going on? What caused my problem?
Excellent. So you mentioned the PowerFlex drives. How does that work? You know, with the safety system and what you can do with it.
So with the PowerFlex 527, it is a drive that's controlled only, well, it can be controlled via discrete wiring as well, but it is primarily controlled via Ethernet IP. So with that, you can send your commands that are non-safety rated to the device, but you can also send your commands that are safety rated to the device as well. You can program your 527 in the same software suite that you program your PLC. that you're going in to look at and see what is this diagnostic of the control system, you can now also see what are the diagnostics of this particular VFD, all in that same software suite. So you gain, basically what you're gaining is time. You're able to see the problem, correct the problem, and get your line back up and running very, very quickly. You're able to eliminate additional components that are added specifically to get you functionality. And you can do it all within the minimal components, so the VFD and the safety controller.
Excellent. So we've got options for encoders as well, right? So in this case, we're going to be able to instead of having that gang of wires coming out of the encoder, now we can go to Ethernet and get some of the same advantages as the drive. Is that right?
Correct. Correct.
Cool. And then for safety I/O as well. So I guess this would help with the issue that we had with safety relays and flexibility there. How does this usually work for a conveyor?
Well, so as an alternative to say safety relays, with safety relays you have mechanical components that are constantly wearing. Whereas in the case of using Ethernet IP safety I/O, typically you have non-contact devices. So without contact, you're not going to have the aspect of mechanics where you are only limited to how many electrical cycles it can have over its lifetime, which is typically millions of cycles. You also have the ability to get diagnostics either directly on the device or back on your control system, so you can see, is this particular input on, is this particular output off? You can control very quickly, and you can see very quickly what is the state of my I/O. There's no having to get a manual out to go see what is going on with this device.
Got it. So I guess that brings up a whole bunch of questions, doesn't it, for integrating these kind of equipment or this kind of equipment into a system and then making it all work in the automotive plant. Tell me about what some of the things that you would think about as you were designing these systems, and what our customers should be thinking about.
Well, so in this particular in the case of mobile automation, so yes, we've looked at ways to make the system more flexible, make it easier to repair, and get you more diagnostics. But that's not the end question. This actually only enables more questions for how do I make this work for my production. So when you're talking about flexibility, typically mobile automation needs to know, well, what type of product is sitting on the mobile automation. Is it style 1? Is it style 3? Is it style 50? And what do I do with those different styles of a vehicle? And also, how do I get that style information back and forth from the traffic cop or the land-based control system? How do I get it to the mobile automation so that it can act on those specific recipes that we built into it? Other things that naturally come up as well is safeties. So with mobile automation, if it's interacting with people or if it's interacting with other automation, how do I get those interlocks to go back and forth? How do I make it so that I don't have equipment crashing into each other or the mobile automation driving off while a robot is interacting with it? There's also questions that come along of, okay, now I have a safety issue. Do I have to shut down the whole system anymore? Or can I just shut off that one carrier? And also with that, if I am shutting off that one carrier, how quickly can I recover when I fix the problem or eliminated the hazard to be able to get back to my normal operation? All these questions and more come up just thinking about how can this mobile flexible system fit into all the other environmental conditions that I have within my plant, especially the automation conditions.
That makes sense. And that brings us to where ProSoft comes in, huh? With all of the network capabilities of Ethernet IP and SIP safety and all of that, comes a pretty intense challenge from a wireless communication standpoint. Talk to me a little bit about how you've seen wireless deployed in these systems, and then I think we'll talk about my favorite topic, which is our RLX2 radios.
So, as you mentioned, wireless or mobile automation. What wireless enables you to be able to do is now have that carrier that is moving around the plant or pushed around the plant. Now having that carrier being able to have a real-time connection back to your system control system or to your traffic cop. So being able to have wireless for that allows you to be able to send both your standard information, which is your diagnostics, your recipes, your start-stop commands, or your different angle commands, but also you can send your safety information. So if that mobile automation goes into a particular automation cell, you can tell it, look, you crossed over this barrier. Now you're inside of this area that is traditionally, if an electrician walks up and opens a gate or trips a presence sensing device or hits an e-stop, that anything inside of that cell now stops and goes into a safe state where there is no motion producing power. Wireless allows you to be able to integrate that type of functionality into the mobile automation and have visibility and control of it no matter where it is in the system. Great.
But ultimately, it's not just any wireless that's going to be able to do this. We talk a lot about designing our radios for the industrial environment, and in particular, the challenges associated with maintaining that safety signal to these carriers so that they operate as reliably as our customers expect them to. I'll talk a little bit about our radios here since this is, like I said, my favorite topic. Our RLX2s are really designed almost specifically for this kind of conveyance application. Of course, the radios themselves are industrial rated, like all of the devices that we've seen so far in this presentation. They need to be to live in that environment of a plant. For us, that means extended operating temperatures. Radios don't normally have to live in a 50, 60 degree Celsius environment, but when you stick them inside of a control cabinet on a carrier out on a line, that can happen pretty easily. We get up, ours are rated well beyond that. The shock and vibration, of course, of moving equipment is very important. Industrial power options, because these carriers are typically have have 12 volt or 24 volt DC, like most industrial networks and most industrial systems. And we offer IP20 and IP67 versions. What really makes our wireless unique and so valuable in this setup are a couple of other pieces of our technology. Number one, we're experts in the radiating cable solution. So where you've got these carriers that follow a fixed path through a plant, putting radiating cable along that path can give you some benefits in terms of reliable wireless signal. Another thing that we do that's really critical for the safety applications is our ultra-fast roaming, and this is well beyond the standard 802.11 type roaming capabilities. As you know, Steve, the safety networks effectively have a heartbeat associated with them, and if that heartbeat is missed for too long of a period, the equipment goes to its safe mode. And with standard wireless that you have in your office or at your home, maybe the speed of roaming is not the most critical thing. However, in these industrial environments, it's absolutely vital. And we've designed our radios to roam in under 10 milliseconds. So that's more than fast enough to support this kind of safety I/O that you're talking about. Finally, we've added NAT and SNMP functionality to these radios. And we'll talk in a second about why NAT is so important, network address translation. SNMP is also very important because it gives some of that rich diagnostic information that you've been talking about to the system. So in addition to getting that diagnostics from your VFD and from your position sensing equipment, you can also now get diagnostics about your radios, on SNMP as well as directly into your controllers on Ethernet IP. So, excuse me. So we look at implementing our wireless solutions on these carriers. You've seen this several times at customers in your area. Talk to me about how this all comes together, and what's so critical in getting this installation right.
So let's start by looking at on the left side of the screen you have the mobile automation. You have a single instance of the mobile automation where you have the safety PLC, you have its onboard safeties, you have the VFDs or servo controllers, you have your position feedback, you have your input and outputs, all that's on board the mobile automation. Well, when you're looking at integrating this into a larger system, that brings us over to the right side of the screen where you see the guard logics processor up in the top right-hand corner. So that guard logics processor is the medium that automation players can use to program how their entire control system is working. Whether it's their safeties, it's their standard control, it's vehicle quality data information. The guard logic system allows you to be able to pull information from so many different areas to so many different devices. Now, where ProSoft radios come into play is, say on the right-hand side of the page, you have the IP67 version of the radio that is connected up to your fixed system side processor. And then it is wirelessly connecting to the IP20 version of the RLX2 radio. And those two, when they're connected to each other, allow you to be able to pass in standard traffic back and forth from that mobile automation carrier. So now you have a control system that is not only just the land-based system, you have all of your mobile automation able to communicate with that land-based system and other devices that are around as well.
Great. So one of the things we've done recently with the product is we added network address translation. This is a pretty, I would say, well-known feature for switches, but you don't really see it on wireless. What does this do when it comes to a conveyance system to really help a customer implement the system?
So when we were looking earlier in the presentation, we saw all these different off-the-shelf devices that are built into the mobile automation to be able to make it work. Whether it's the safety PLC, the I/O, the VFDs, the encoders, several different Ethernet devices on board that carrier. What network address translation does, it allows you to keep all the devices that are on board that mobile automation that have to communicate. It allows you to be able to let them talk, say, just to that safety PLC that's on board, and only the safety PLC on board talk to that land-based control system. Now, the reason why this is beneficial is because, let's say you take a control system, in this particular case, that has 130 carriers on it. Well, if you take those 130 carriers and you multiply it times the number of individual devices that are on board each carrier, now you have a massive amount of devices that are trying to communicate all at one time. Now, where that is a problem is when you look at wireless, or even when you look at wired Ethernet, but especially wireless, you have a set amount of bandwidth that you can use. And being able to narrow down only the information that needs to go back and forth from that mobile automation to the control system allows that information to be able to move faster, quicker, and with less interference or collisions as it's trying to get back and forth from the mobile automation land-side system. So what network address translation allows you to be able to do simply is keep your system from being flooded or overloaded. Okay, so one other benefit that comes from using the network address translator is the ability to make every device that's on board, say in mobile automation, be able to have the same IP address. Where that is important is when an electrician goes to repair or replace a device that's on board, they don't have to go look up in a drawing set or a table to see what is the IP address for this specific carrier's VFD1 or this specific carrier's laser scanner. They can replace that device and know that every single laser scanner, for example, on any of the mobile automation can have the exact same IP address. In this particular case, the 192.168.1.6.
Yeah, that definitely sounds a lot easier. And I can imagine if you're the system integrator or the OEM in charge of starting up one of these systems, having to deal with 130 carriers all with different IP addresses would be a headache as well.
Correct. So being able to use the network address translation takes it from being, say, over 1,000 IP addresses down to, say, 130 something IP addresses that you have to maintain.
Right. Yeah, just one IP address for each carrier. That makes sense. Okay, so now we put it all together, and this is what we have for a system. So we've got our Ethernet IP system connecting all of these devices. They have rich diagnostic data coming from everyone. They're easy to maintain and replace. And we've got wireless connectivity that is reliable and gets that information back to the controls and to the folks in the plant exactly when they need it. And all of this gives us more flexible automotive building. Is that how that works?
Yeah, that's how that works.
Excellent. And then we put it all into a big line. And this is not necessarily theoretical here. 130 carriers, all moving product through a plant with the ability to operate independently and safely, all with very reliable connectivity.
Correct. Yes.
All right. So kind of wrap it up, give us a summary here of why leading automotive companies choose wireless and safety networks to do their conveyance.
So Keith, as we discussed at the beginning of this presentation, that the goal is flexibility, increased quality, increased safety, lower time to diagnose or repair something, and overall uptime for that control system. So a wireless and network-based control system or safety system for mobile automation allows you to be able to take mobile automation and put it inside of the stringent conditions that are required in a automation system, or especially a automotive automation system where people are working around it, and have the mobile automation to do exactly what you programmed it to do what the traffic cop allows it to do, and allows the traffic cop to monitor at all times what's going on, It allows you to be able to get that information back to your upper level systems so that you can react quicker instead of having a fault condition stop your production line. You may be able to get your maintenance over to address the issue before production even realizes that there is a problem. So ultimately what it allows is you to make more vehicles.
Excellent. Yeah, of course, it also opens up IIoT for smart conveyors too, right? That kind of gets to that idea you're talking about with information coming from all of these devices and allowing the plant to make better decisions around maintenance and identify problems that recur to make things more robust as they go. So connectivity is key to all of that. And again, our wireless solutions here are really designed, custom designed for this kind of application. Again, we've seen this a lot of your customers over there in the U.S. Center of Automotive Manufacturing, but we've seen this around the world as well, where automakers are really taking to this idea of smart conveyance, and they're really benefiting from the unique properties that we built into our wireless system to make it all possible. I want to thank everybody for joining and watching this video. I hope you found it informative. I really want to thank Steve for sharing your expertise in this area. It's really great that we've got somebody like you on our team who really understands this application at the highest levels. And feel free to contact ProSoft Technology with any needs that you've got for wireless. Thanks a lot.